Okay guys, we're gonna start soon, but before we start with the presentation, let me ask you some questions. Is everyone here from Cyclum, or we have other companies? Who's from other companies, not from Cyclum? Come on guys, nice to hear you. Nice to have you here, that you found the time to get to the PTA at the evening. The second question, is anyone here have already experience with machine learning? Who has? No?
It was small experience. It was just in courses, but we never used it in production because they was fooling us about we will do it.
Okay, so the rest shouldn't worry about that as we start with some basics. Okay, I think that's enough time, right? Can we start, Christina? Okay. So, today we're gonna have a talk about quality assurance in the project with machine learning. Just a few words, I'm not an expert in machine learning as well. I only know about the testing of software. In my free time I enjoy working with Python and machine learning, so I'm gonna use my experience and share it with you, how not to repeat all my mistakes that I did in creating this project. So please listen to me, and I'm really glad to have you all here. Few words about myself. My name is Pavlo Strumkin. I work here in Cyclum as a QA automation. My project is the FashionNet. I worked with Java and .NET stack in my free time, as I said. I enjoy Python and working with machine learning. Those are my contacts, so don't hesitate to contact me if you have any questions, because after this talk, you're gonna have more questions than answers, so please don't hesitate to ask. A few words about the project. The idea of this project was the mobile application for small kids who will try to master the skills for writing letters. So you can see the client side here is the mobile app, when you can draw a letter, then press a button and send it to the server side, when we have the neural network which will try to recognize what kind of a letter is on the image, and then responds to the client if you did good or bad, trying to recognize it. And before we deep dive and talk about machine learning stuff, we're gonna have some brief introduction. What is machine learning? What is the data set? How to build a model and measure its quality. Then we're gonna deploy our model to the server, and we're gonna talk what you need to test there. Of course, we're gonna talk about mobile application as well. Few things, because the mobile application is not big enough. And the last step also important here, as we're gonna talk about post-deployment support. The interesting part here is that machine learning depends on the data, and data changes within the time. So we're gonna need to track how good is our mobile application, and machine learning model works with the real data in real time. Why, as an engineer, you should care about that? I noticed several facts that machine learning does pretty good and show really perfect result in some particular areas. So business want to invest more and more money, which means that demand for the specialist will only be growing in recent years. So if you want to fulfill this need, you should be interested in that. Also, that's easy to start with machine learning, and it's really fast to learn, to search for an open course and start with the basics, as well as it's hard to master the skills. If you go to the Kaggle, where you can compete with other guys in skills with predicting some values, you're gonna find that to get the top scores and top places, it's really hard. You may lose your time for sleeping if you want to do so, and this is interesting for me. And again, because the field is under development, we still have a time for creativity. For example, for talk like that, by assuming how QA gonna fit the process. So let's take advantage of this. Of course, if on your project you have machine learning and you are QA on this project, your responsibilities are to assure the quality of this project. So to perform those actions, you should of course know how it's built in order to check that the process of building it fulfilling all the quality requirements. A few words about the history. The machine learning is not something new and was developed almost 70 years ago. The reason why this topic is on hype right now are several. We have data more than ever, we have computational power more than ever before, and we have much more powerful algorithms that allow us as a people and data scientists to fail faster and come up with the new ideas. Before, it was taking months to try something. Now it can take hours, minutes. Here is the definition. What is the machine learning? The field of study that gives computers the ability to learn without being explicitly programmed. So we're going to use this description to teach our model on some part of the data and check that it works on the data that it never seen before. That's why we're going to try separating this data, not to feed in all the data in model to fulfill these requirements. You of course seen some pictures of the neural networks, and just for you there are lots and lots of more algorithms of achieving the idea writing a program without being explicitly programmed to work it on the new data. The neural network are the one of those algorithms. In fact, it's not correctly an algorithm, but more like a framework for developing algorithms. For you, as a QA, it shouldn't be interesting what is inside of the model. Treat it like a black box. In fact, it is a black box. Even experienced data scientists cannot get just into the model and check why it come up with certain answer and not another. That's why we're gonna put more effort on the steps that go before building machine learning model to make sure that it will gonna take all the benefits of our data. And we don't need to debug deep in the networks. I'm taking advantage and showing you your first MEMS in the area of machine learning. As more as you go into this field, you're gonna find those images funnier. Maybe we're gonna try to check it after the speech if you find it more funnier than before. So this is gonna be good for me. And for explaining some of the parts of the speech and some of the concepts, probably image recognition is not the best case for explaining them. So I'm gonna use some more examples from the competition that I took part. One of them is the house price prediction, when you have the information about the property, its size, number of bedrooms, for example, and you were predicting the final price of the house. The next one is taxi trip prediction, is where you have the start point and end point of taxi trip. Your goal here is predict the length of the trip. And PUBG finish place prediction. Maybe some of you already played this game and we have your statistics. So on this competition, we took the player statistics, trying to predict what will gonna be the final score of the player. So don't repeat my mistakes. As a QA on the project with machine learning, try to make sure that you have requirements for the project. I was so involved into trying new stuff and making model more complex, trying to achieve the higher accuracy as possible, that in fact is not the same what I was looking for. If you want to teach the kid how to write a letter, you don't want to model to recognize every scribble. In fact, the letter should be properly written, right? So we're gonna put some limitation here. We're gonna teach our model only work with Russian and English alphabet. The case will be upper and lower case. We need to define it because we need to prepare data for those cases. The font will be only handwritten, so we're not gonna talk about typed letter, as you can see here. Those are the types letter. And this letter slope will be from 0 to 45 degree. Here you can see 0 and around 45 degree the slope of the letter. So please prepare requirements before diving deep and trying some stuff with the model. As fast as requirements are done, so let's start with collecting the data. There are several ways how you can collect it. Usually the best one is to sit with the pen and the paper and just write everything by yourself, take a picture and label those images that you have. It will take lots of time, but the benefit from it could be really significant, because the more close the data will be to real examples, the better it's going to be for your model. Another option is to go and find images on the internet, again collect them and label, also an option here. And the easiest point here is what I did, is the find prepared data set in internet. There are lots and lots of already prepared data set for you, starting from kittens and dogs, finish it with the cells that are affected by malaria or not. And you can compete with other guys trying to predict if the person is ill or not, and maybe make some revolution in the medicine. Here you can see the example of my dataset that I took from Kaggle. Those are the images, and on top of them you can see the labels. We will use this for feeding the model. Take some notes that the dataset is the core of machine learning. The better dataset, the more accuracy and the more correct the answers will be for you. So here is the real example of it. When you already work with dataset, you may find several problems that I want to show you. One of the problem that you will get for sure is that dataset contains not enough data. The same as with real human and real kid. How many times he should see that how letter could be written before trying to recognize it. He should really see several examples, and he should see all of the possible examples before checking the image and making sure that probably this is the letter A. The same for the model. You need to collect all the data, and don't think that it's possible to go into the data set and check them manually. It's very difficult. For you here, the key skill will be the data visualization. You can find lots of tutorials again on Kaggle, on YouTube, because you will need those skills trying to clarify how good is your data set and what is really inside of the data set. Here you can see the pretty good distribution of all the letters in the alphabet. This is the Russian alphabet, don't get scared. And we have around 450 images for each. Is it enough for our model? We don't know. Let's try to check it, and after seeing the result, we'll make a decision. What is really not good is this kind of distribution, when some of the letters are even absent in your data set, or sometimes you get really few examples. This is definitely the place to work, and you will need to fulfill this and fix this problem. This problem takes lots of the time, and probably our responsibility as a QAs will also be trying to get this data. Collecting the data from several sources. I'm not talking only about images from internet. This data could be taken from other databases, other services, and it's really possible that some data will be missing when you check what is inside. So here you can see that even in our data set, we have some places where there is no image for the letter, or there is no label for the data. For machine learning model, this is something like a null pointer exception. You need to fix this, and usually you can just remove the observation that contain the missing data. We don't talk about how to fix it, more about searching for it. It's quite easy to spot the missing data. There are easy examples how you can do it. You can try it in Kaggle as well. The more harder thing to catch are the outliers. The outliers are the observations that are distant from your other observations. That sounds pretty tricky. And really, indeed, for images, it's quite hard to distinguish what are the observations, what are of them are outliers. In our case, I was checking the data set, trying to find images that I don't want my model to see, and to know that This letter, for example, can be written like that. No, I want my model to see only properly written letters. That's why I'm removing those kind of outliers. If we talk about table data, and example is the PUBG finish place prediction, just imagine that you have a statistic of a player that used cheats. So he cheated and probably he didn't even move a single step in the game, but still got 5 headshots in a row. You don't want your model to use this data and trying to say that for winning you shouldn't move and get around 5 headshots in a row. No, those are the outliers. Searching for them is really difficult task, and for you it will depend on the problem that you will be solving. So in example of the images, you will need really to go into dataset and manually check all the images that you have, trying to get the outliers as the possible way for searching for them. When you remove all the data that is not useful for you, you may find that there is not enough data. The way how to solve it, one of the possible ways for images, is to generate a data from existing one. For example, by introducing some distortion or some rotation. But you may remember that we got some requirements for us, and we don't want our images to be flipped upside down or to be completely reverted. So after generating data, and if you know that your programmers are using data generator, you should you should also test it and make sure that this data generator does not provide you some outliers that you don't want your model to see. And of course, if you are solving the problem trying to recognize the letters that are written by doctors, for example, you know that they are using some different font, right? So make sure that your data set also contains this data. I did a crucial mistake in my data set because I took it from internet and it was written by adults, not by kids. So how can I be sure that the letters that are gonna be written by kids will be similar to letters that are written by adults? It was really a crucial mistake, and I get the problems because of that. So don't forget that your data set should contain domain-specific data. When we're talking about data sets, one important thing to mention here are the features. So what are the features? In case of images, the features are the pixels of the image. It could be 1000 by 1000 pixel image, or it could be 32 by 32 pixels. All of them will be transferred to the matrix of numbers that will represent the pixel intensity in every point of the image. It was found out that for letter recognition, it's not really important to use 1000 by 1000 pixel image, and it's really it shows good result even with smaller image, even less than 32 by 32 pixels. For you, it could make a difference because the neural network will be different. One with 1000 inputs and another one with 32,000 inputs. As inside of the matrix, we have operation of matrix multiplication. You may understood that multiplication of matrices like that will be much slower than multiplicating the small matrices. So you will need to make sure that your features are enough for your task. If we're talking about face recognition, probably 32 by 32 is not enough. Not to have kind of this image and trying to predict it, right? If we talk about table data, here you can see the examples of PUBG finish place prediction, and features here are the columns of the tables. This is how much we know about each player, how much damage he dealt, how much swim distance he took, wall distance, weapon acquired. Is it enough feature for us? We don't know. In fact, it could be tested like that. Just imagine that we are trying to predict the house price, and we take the real estate agent and show him the price, show him the house only by saying how much bedrooms in it. Is it enough to say what is the price of the house? No. The same for the model. The model should take the reasonable amount of data about each observation in order to check that the results are predicted correctly. And if it comes to the creating of a new features, here when the real data scientists come to, the process of feature engineering requires domain knowledge, requires the knowledge of statistics, and requires a lot of skills in data science. If you go to the top of the places in the competition, you may find that even all of them using the same algorithms, the same neural networks, but the results are different. The feature that you can build and create from already existing one makes a difference. Just imagine that you're trying to predict how long will taxi trip take place, and knowing only by start point and end point probably not enough for you. So people who won this competition add the features, for example, like what is the weather right now? Is it raining or not? It makes difference. If it is rush hour or no, it also makes difference. Some of them even collected the streets that people, the taxi driver will use, and get the data from some government institution to check is this street is under construction or not. So this information is really important, and the skills that you need to collect this information are really important and hard to find. So good data scientist gets real money for that. Just to sum up, several examples what issues you can find as a QA here. For example, the not enough examples of letter K refers to the not enough data. Dataset contains corrupted images. This is referred to outliers. If you found them, you can register an issue and ask your developer to remove it, or even remove it by yourself. And the next one is that images are not labeled. This is about when we have not available data and we need to clean it, otherwise we're gonna fail. The good part here for you as a QA is that all of those steps that comes from gathering the data, cleaning the data, feature generation are written in code. And what is written in code can be tested and should be tested by unit tests. As a QA, you could make sure that those tests are properly written. This is the example of some of the tests, of the simplest test that I can come up with. Let's pretend that one of our steps is to clean the missing data. So we can use the array with the data that is missing. You can see it here. We pass it to the clean missing data method, which we expect will clean the data, and we can assert that as the result, the data is not there anymore. This is the example of unit test. As long as you have the data already prepared, you can start with creating the architecture for your neural network. We are using convolution. We're going to be using convolutional neural networks as they showed pretty good results in image recognition. You don't really need to know what is the convolutional neural network or what is the architecture. Let this information to be on the side of a data scientist. I just shown you some example that right now, with the help of a new frameworks, it's quite easy to create networks by yourself. You can see that the layers are stacked as steps in your test. You create the object of a model and you just add. That's it. The interesting part here that you should know what you should add to here, but this is on the side of the data scientist. You may notice that there are lots of numbers here, right? How do you know that you should use those numbers? First of all, you should know the linear algebra and all the math that goes behind the neural network. And you should try new combination of those parameters. For people who are not aware what is happening in the scientist layer, it may look like this. You just trying, failing, trying again. This is how the tweaking neural network happens. For you as a QA to understand if the model needs some tweaking or not, there is there is an algorithm for checking this called cross-validation algorithm. Sorry, cross-validation technique. In this technique, we're gonna divide all our data set into three parts: train, validation, and test set. In percentage, this could be around 80% and 20%, and here again 80 and 20. Again, it's quite discussable questions. It's completely related to your task, and you will need also to try those parameters. Your task here as the QA will be to assure that all of those sets, small sets that we build, also contain all the examples of our information. Because, for example, if you train a model on the letter A and test it with the try and recognize letter B, what do you expect on the results? It will be zero accuracy. So before teaching the model, it's easier to make sure that this distribution, this information is correctly distributed among the data set. And the whole process of teaching the model is the process of searching for a function. You don't really need to know how the process is going on. For us, the best part here is that there is always a numerical representation how good is the function doing with your data. On this example, we can see, and let's pretend that model come up with this kind of a function. So we can try measure the error by drawing the lines. What data is, how far the data that we have is distant from here, and then try to rotate this this line to get the less average distance between the points. So this will be our error matrix. In our case, the process of teaching the model was looks like that. We started with the loss function, which is the numerical representation of the error, is the 3.5, and accuracy around 0%, which is fine. We ended with the loss function decreased to 0.15, and accuracy on the test set 95%. Pretty good results, right? But when we came to checking on the validation set, which means that we check on data that was unseen by the model, the loss function was almost the same and accuracy was 3%. So this is not a good result, right? This is called the overfitting, when model remembered your testing data but failed on the data that was unseen. More or less fine result will look like that. So the accuracy is 78%, not the best accuracy, but the good part here is that on validation set, it's also show the good accuracy. You cannot get 100% of the accuracy unless the model will remember all your examples. So around 95% probably will be fine for your project. For us, for my project, it will be fine even with 85%. But it's not enough. The percentage of an overall number of letters is saying only some general number. If we go and check how good is it in recognizing different letters, we may find that, okay, we have error rate of 40% for recognizing letter K. Something is wrong here. To fix this problem, you can go and check your data set, tweak your model parameters, try different things, but you will need to fix this problem. Your task as the QA to help the data scientist find those problems. Just to summarize, the examples that you may find here is the model is underfitting training set, which means it fails even with testing data. Model is overfitting training set. Oh, sorry. A model is underfitting training data set. It fails even with test data. Overfitting means that it memorizes the testing data but fails on unseen data. And as we saw the example, that we have low accuracy for letter K classification, which was further investigation. The way how you can improve it is, again, change algorithm, tweak parameters, add, remove features, or getting more data. Usually it's always an answer for any problems in machine learning. When we build and we satisfied with the accuracy of the model, let's upload it to the server and provide some APIs for interacting with that. The responsibility of the API will be loading the model, get an image from a request, process an image, and response with the prediction. As you may see here, there is nothing related to checking the accuracy. And as a QA, you shouldn't check accuracy of the model on this step because you should invest and check it on the preparing dataset and training the model. The bug examples that you may find here completely relate to the server side, which means the image size is not limited and you can upload whatever size of an image, and it's worth trying the performance testing of the API. Input data is not restricted to image extension. Also the problem that is completely related to the validation and cannot get prediction for an image with GPG format. Probably some of the backend developers forgot to include this kind of extension and parsing this kind of image that comes from the request. Nothing related to data, to accuracy of the model. With the mobile application, it's almost the same. Responsibilities are clear and shown here. Draw image, send an image, show the results to the customer. We don't need to write a test that will check all the data from our testing set. No, we should enrich this testing set on the step of creating the model and training the model. And it's also not only the question of adding the cases to the test set. You need to assure that this data, similar data, is also included into training and validation set. And this data cannot be the same images, as model will just remember it and fail as an image on the real data will be different. The bug examples completely related to mobile application. Send button is not shown, which means somebody forgot to add it to the layout. Result is not shown after getting response from API. Refers to the cases when payload from the response was changed and we cannot parse the answer from the server. Application crashes after rotation. Again, nothing related to the accuracy of the model. You may still try to search some cases when your model is failing and you may report them. You should only know that better to do it on the steps that came before training. Otherwise, you may lose some hours or even days that requires to create a new model. And when the model is already released and you have real data comes into your application, it's really important to make sure that it still works, because within the time data gets outdated. Maybe with images, it is not something usual and the letters are not changing. But in our case, the letters that were taken as the dataset were written by adult human, and we need to check that this information is also works with real data, that real customer sending to the API. And again, we can plot this information and make an analysis. How good is the accuracy of the model? The way how, as a QA, you can improve and make sure that this step is done, for example, by monitoring accuracy and building some tools to gathering and logging the data that was sent, making sure that you have the responses from the server, and you can manually check that this image shouldn't be recognized, or this should be recognized. I'll add this image to the data set and will try to teach the model in the next time. You can also do it in real time by sending the image. I'm not sure that it's really applicable with image recognition, that you will just from the scratch get the data and train the model again, but also it's possible that the system in real time adapting to the changes that you get from a real data. The next point will be about resisting adversarial attacks. This topic is really huge, and I'm encouraging you to check it by yourself in internet. Some few words to make you interested in that is that just imagine that your model recognizing the images of the cat, and it does pretty well with the 97% of accuracy. It says that this is the cat. Just imagine that some guy can build another neural network to generate a mask and add it to your image of the cat. And for you, you won't get any difference, but for the model, you can see that prediction is pretty different. So now it's a dog. And what if your project is the face recognition, recognizing images and unlocking the phone? It could be a problem. For fulfilling those kind of problems, you will need also keep track of new things in industry to make sure that you are doing fine. As a conclusion here, I would like to say that for assuring that something is built properly, of course you need to know how it's built. Maybe it's not about some details, but at least in overall scope, you need to know it. And of course, if you ask me if machine learning will solve all the problems in the world, my personal feeling is it won't. It's really good in solving of problem of certain type. It's our problem as the community that that marketing is saying that we can solve all the world's problem. No, we won't. And of course, machine learning will not replace the QA. You already saw that it introduced so many new problems that you need to check as a QA. Your task will be here is to make sure that your skills are enough to fulfill this need. Here you can check some URLs for site that you can manually upload the images and get the results. This is just an open API for trying and playing with the images. Also, you can get the source code of the model, how it was gathered, trained on the Kaggle. API, it's also open sourced, so you can check what is written inside of the server and come up maybe with more ideas for the test. And mobile application, thank you Kostya for creating this application for me and letting me use it in the project. Please also participate in trying creating a pull request, it's also welcome. And for you, if I was succeeded in getting you interested in the field, here are the resources that you may find interesting. The Coursera, this is the free course from Andrew Ng, who is the father of deep learning. You may enjoy watching his lessons. Kaggle, this is the platform for competing with the other guys in solving machine learning problems, and just a pretty good source of resources, of information. And also they have some basic examples. So if you want to try with something easy, go to the Kaggle and go to the learning part of the site. And YouTube, please check Saraj Rewal. This guy is amazing. He started the worldwide initiative which called the School of AI. It's in an open source community when you can go and check if in your city, we have it in Malaga actually. In Malaga we have School of AI, and guys are creating some meetings and sharing the knowledge completely free. You can find it in meetups, Malaga School of AI. That's all for me guys, thank you for watching and I'm ready for your questions.